On this episode of Extreme UTV Tech, we're going to be building a roll cage for this 1000cc RZR. Alright, so we're going to show you guys today how to build a roll cage. We're going to use this Polaris RZR 1000 and we're going to start off with a design, then we're going to go through the tube bending, we're going to go into notching and welding all the way through the whole process. So stay tuned because this one's going to be a good one. So the first thing that we have to do is come up with a design. So Matt, tell us a little bit about why you're building a roll cage and what design you want out of this roll cage.
Okay, as I've gotten into racing, probably one of the first things I really wanted to do, but I haven't had the ability until now, is a roll cage, because the factory ones, they're a lot better now than they were when they first started building them, but they're still not up to snuff when it comes to the high-speed racing that we're trying to do. So I definitely want something that's lightweight, because the lighter it is, the faster it's going to be. So I want it lightweight, but we want to keep it fairly strong as well.
Okay, so what we're going to do is we're going to use an 095 DOM tubing because it's a very strong tubing, but it's also lightweight. It's going to give you what you want for that perspective. The next thing that we're going to do is we're going to put you in the RZR, put a helmet on you, and then we're going to measure from your helmet up to the top so we know we have the right roll cage clearance. All right, Matt, now that you're in the buggy, we want to take a look and see basically what the difference is between the top of your head and this roll cage. So let's take a quick measurement. You've got 7.5 inches, and we want to have about 2 inches of clearance. So we're going to chop this cage about 5.5 to 6 inches. One thing else that we're going to do, if you look at the way this bar comes off the top, it's directly above his head. So what we're going to do is we're going to take that bar and rotate it outwards so that it comes from this point down to this point, your A point and B point pillars, and that's going to keep that roll cage off his head a little bit more. You feel pretty comfortable right there?
Yeah.
All right, good deal. The first step that we're going to do is we're going to take all the old bolts out of this cage and move it off to the side. Now that we have the roll cage off, you want to pop this open right here. There's another screw, 13 millimeter. Go ahead and take it off and then pull your doors completely off both sides. One of the things that we normally do when we have a RZR roll cage is we cut these feet off. What I'll do is I'll chop the tubing here, chop the tubing there, bolt this one to that one, put it in the lathe, and basically cut that weld out. The reason that I do that is because the factory mounts right here have a hole that go through them so that you can run your speaker wires if you want to put a radio on. Now, Super ATV sells these right here. These are replacements and they already have a hole drilled. You can get these from Berkey Racing or straight from Super ATV. You'll see what I'm talking about. All right, once you get all your cage feet bolted on, you're going to have to take some measurements. So what we're going to do is we're going to measure from this point to this point. We're going to take that measurement, we're going to write it down. Once we have that measurement and now that we know the length, basically what we're going to do is create a box on paper and we're going to figure out what our angles are going to be to come from this point to that point and connect the dots. Right, the next thing that you're going to need whenever you're building a roll cage is just an angle finder. I got this little one from Harbor Freight, works perfectly fine. You're going to have to get the angle of the front A-pillar as it comes off the RZR. Once you get that angle, then you're going to use a protractor, take that angle, and you're going to transition it either over to your garage floor or some sketch paper. Once you get to the point where you're actually going to take that and run that angle up, you know what the point is because you've taken the measurement between the A pillar right here and the B pillar right here. Once you take your angle and you run it up until you get the height of the cage that you measured in the first video. Once you get the height of the cage, you can figure out exactly what your angles are going to be to create the full box. Using your protractor, a straight edge, your garage floor, white paper, or you can download computer software called BendTech that works really well. For a beginner, it's phenomenal. If you've been doing it for a long time, you get to the point where you can probably knock this stuff out pretty quick. So the next thing that we're going to do is we're going to get the length of all this tubing and then we're going to go over and show you exactly where to make the bends. So if you've just got your bender and you're trying to figure out how to build a roll cage, or even if you have a bender and you've been building roll cages, one of the best things that I've found to help me out with building is taking a number of pieces of tubing and bending them to different angles. So what I've got here is a 45, a 90, I got a 30, I got a 15, I got a 10. And what I do with those is I go up to my roll cage, I find the spot where the bend starts, and if you look real close, there's actually a little bit of an indentation. That's where the bend's going to start, and that's where you put the mark on the bender. You can walk up to your roll cage if you have that mark and you know what the angle is, and just take your piece of tubing, put it up next to the other piece of tubing, and mark out where your bend needs to start. So here in a second, we're going to pan over here, and I'm going to show you how to do that. All right, so what we did was we put our angle finder on this bar right here, and what we do is we go from here all the way over to here, from your A pillar to your B pillar, and I draw a straight line. Once you know that line and you know exactly how tall the roll cage needs to be, because we took a measurement earlier from our occupant's head, now what we're going to do is we're going to take our bend. We know what degree we need to choose because we've already plotted it out over there on the board, and we're going to take that mark and we're going to transfer it over onto our tubing. Once we've transferred that mark, I know that if I start that bend right there and roll that piece of tubing down, it's going to end up at the right elevation above the occupant's head in the exact spot where we planned on it. But what you can tell is that I've got these marks, and this is going to be consistent with every bender that you use that's a draw bender style. If you look inside the die, you'll notice after you bend a couple pieces of tubing that there'll be a mark. That mark is where that piece of tubing rolls on the die, and that's going to be the start point. So if you know that that start point is right here on that blue mark, that's basically where those two blue marks are going to run. So the next thing that you're going to have to do, take the piece of tubing, slide it inside the bender, line up your two marks, and start your first bend. Now that I've got the tubing in the bender and I've got a little bit of clamping force on it so it won't rotate, you're going to have to use a rotation gauge, put it on the tubing and clamp it down, because all of our measurements and all of our angles and all of our bends are going to come off of that particular first bend. So you need to know what the rotation of the tubing is so that you can make rotation bends on plane or off plane. In this case, all of our bends are going to be on the same plane, so I'm going to set this up for 0 degrees. On this particular bender, we're bending going up. Some benders go to the side. On this particular bender, you have to take into account the slope of the tubing coming off the back of the bender. So in this particular case, I have 4 degrees of slope going down, which is going to subtract from my total angle up here on the front. So up here on the front, my target is 45 degrees. I have 45 plus this is going down at 4 degrees, add 4 degrees, at 49 degrees is what our total bend's going to be. Now, every tubing has a certain amount of snapback. It's basically the paperclip theory. When you bend a paperclip and let it go, it kind of snaps back a little bit. Tubing does the same thing. Each style tubing, each size tubing is going to have a different snapback. In this case, a DOM tubing of this size, the 095 or the 120 wall, usually runs about 2 to 3 degrees. So we're going to try to take our measurement. If it's off, then we'll go to 3. You don't want to bend too much. .51 degrees. All right, now that I got my helper over here helping me out, we're going to take the measurement that we got earlier and we're going to make sure that that tubing is sitting right where it needs to be to give them the proper head clearance. So we're sitting exactly where we need to go, but what you notice is that we have a 5-degree slope coming down. So if you take that 5 degrees coming down and then you take a measurement off of your B pillar, we're at 72. So I know that I'm going to have to be more than 90 degrees to be able to make this bend up. Instead of doing it in one big swoop and coming way back, I'm going to do it in 2. It's going to make a nice little smooth transition from the B pillar back to the A pillar. Now that we have our tubing marked for our second bend, I went ahead and lined up my die mark with my tube mark, then set my rotation gauge to 0 so I know that both these bends are going to be on the same plane. Next thing I'm going to do is make my second bend, which happens to be 69 degrees, which is the 5 degrees minus the second sweep that I'm going to do. So we're going to bend this to 69 degrees and go and get our third bend. All right, so now that we have our first bar bent all the way around, we've got our first bend right here, second bend right here, third bend right here. What we did was we set it up on the RZR and basically took a side view of it, got down and looked at it as best we could, and we found out what our elevation was over the driver's head, and we made a mark exactly where we're going to cut this thing to drop it into the RZR. So if you look at the end of this tubing, you can see where I actually ground it down at an angle, put a little chamfer on there, and the reason I did that was so that I could get solid weld penetration between the piece of tubing and the A-pillar. All right, so we got the first bar bent and it looks really good. We've actually got a good gap right here we're gonna weld up, a good gap right here that we're gonna weld up so everything looks nice and smooth. We've got the elevation that we want for the driver. Now what we have to do is we have to repeat everything that we just did. So we're gonna use this as a template and we're gonna set it on the ground and transfer all of our measurements over to another piece of tubing. All right, take your two pieces of tubing, set them side by side. Now that you have the mark at which you started your first bend, all you have to do is transfer that mark over to your new piece of tubing. Then you're gonna bend the same angle. Once you get that done, you're gonna set this one on top of this one, take that mark, put it on this piece of tubing, and can keep on doing the process until you're all the way down. Okay, so now you can see that the two bars are bent identically. You've got the top bar, which is our second bar, matching the first bar. And what we're gonna do is we're gonna cut it off so it's the same length. Anytime you're bending tubing and you have two different pieces of tubing, whether it's left side, right side, front, or back, as long as you make it to where it's mirrored, you know that everything is gonna line up perfectly and everything's gonna be square in the end. All right, now that we have our two main bars into place, we're gonna do a couple structural bars to hold everything together. We took a measurement between the two bars. We're at 35.5 inches. We're gonna take a piece of tubing, cut it off, do 2 notches, set it up inside here, then we're gonna hold everything together and move it back and forth until everything is square before we tack it up. So the next thing that we did was we took a measurement on the back side of the roll cage, came up to 39.25 inches. So I've got a mark here and a mark here, that's 39.25 inches. I found the center of this piece of tubing, and then what I did was I came over and took those two marks and lined them up so that this mark is sitting where it needs to be on the inside of the cage and that mark's sitting on the inside of the cage where it needs to be. That's where these little pieces of tubing come in handy, because I know exactly where my bend is going to start and stop, and I know exactly how far back I want this to sit. So basically what I can do is I can project where that tube is going to intersect over here on this top bar, and then I can project exactly how far out I need to make this mark. So take a tape measure, we'll come out here, measure out about 9 3/4 and do the same thing, and that's where we're going to start our bend so that we know that it's going to kick out and go straight back on the other side. Yeah. Okay, so what we did was we went ahead and put all the bars inside the cage for the top to make the box. And what we're doing is we're using ratchet straps to hold these two bars in. Now we can actually rack it back and forth to get it all square before we do our welding. This ratchet strap right here is actually pulling the cage left and right. These two right here are squeezing it together, and we can position everything to where everything is right before we do our final. Now we've got the entire main structure tacked together. Everything is where it's supposed to be. We got some heavy tacks on it, so it's not going to move. The next thing that we want to do is go back to these back pieces. The reason is the more points you can get on the chassis tack welded together, the less probability of all this stuff moving on you. So what we do is we take a part that we've already bent, and we're going to set it inside here and kind of eyeball exactly where we want it. Now, in this particular case, I wanted that bend to be right about there so that it's going to line up perfectly with a roll cage, and then I took a straight edge and came down here to this bottom piece. Once I got that done, I transferred the numbers basically directly over to this other piece of tubing. We went ahead and made our bends, and we're going to go ahead and get it tacked in. Now we've got the main structure of the cage all tacked together. We've squared it up, we've taken all our measurements, we're happy with everything. We're going to go ahead and weld the main structure together so that everything is solid. Once that's done, then we're going to start putting all our cross bracing pieces in, all our smaller stuff. That way, whenever we tack weld anything small or all the cross braces, it doesn't pull the main structure out of square. Oh yeah. Oh yeah. Now we're going to do that corner over there. The heating and cooling of metal generates a substantial amount of heat. You don't want to do welds on the same side of the roll cage, one after another. What you want to do is start a weld over here and then jump to the other side and do a weld so that any type of contracting from the weld cooling process isn't going to rack the roll cage. Man, I feel like a professional. When you're welding tubing, the goal is to start and go all the way around the tubing in one shot. That way the heat distribution goes all the way through the tubing, you don't have any cold spots. But if you can't do it, don't worry about it, because I can't either. Talking about earlier. So we go from there. Okay, so we just got done welding out the top part of the cage. Everything stayed square whenever we welded it, and the reason we did that was just to hold everything square while we do the next couple pieces. If you look, we've got this bar running down the bend just a hair, so it's lower than the elevation of these other bars. We're going to do a flat roof on here, so in order to make this piece of tubing go from the back B pillar over here to the front pillar, you can see that there's a gap. So we're going to have to put a small bend in this piece of tubing so that it raises up and hits perfectly flush and still can cope into this piece right here. Okay, so the last thing that we did was bend these two bars, and you can see that as they come down, they roll at the same point as these outer bars. And what that's going to do is that's going to give us a nice flat roof all the way across so that when we put our sheet metal on top, it's not going to have a bow in it and it's not going to rattle as bad. Now we've added this bar back here for our harness bar, and we're going to take two bars, small bars from right here, and we're going to drop them down at an angle so that any impact coming from the top of the roof is distributed into a number of places. You'll hit here, it'll distribute down through here, it'll distribute down through here. It'll also bring that load all the way down through here and help triangulate the top of the cage. Race gauge.
Race gauge.
Okay, so as you can see in the back, what we did was put our two pieces of straight tubing in so that in a rollover situation, those two bars would be under compression. That's the strongest way that you can have a bar. If you had a hit, it would put the force down through that bar and distribute the load. The next thing that we want to do is we want to build a front cage that's going to be good for eyesight. So instead of just taking a bar and going straight across, what we did was we used a bend that we already have, and you can see our yellow marks there. That's where the bend starts and stops. And we used that to gauge exactly where we needed to do our bend, basically where we wanted to start it and stop it. So what we did was we made our couple marks out here. We're going to make our bends, cut the tubing to size, and then we're going to do the same thing up front. But in the front, we're also going to do what we did like in the rear and do some straight bars coming down so that any type of rollover is going to distribute the load and triangulate the front end. Show how to bend it and all that sort of thing. This thing came out awesome. We got all of our bars put in exactly where they need to go. Everything's tacked up. We got our welding blankets down. We're going to do our final welding. Once we get our final welding done, then we're going to go back and start working on the front and rear bumpers. But this thing came out killer. Okay, so if you notice, we've got everything welded up, and now we're going on with the tabs to hold the seatbelt harnesses on. What I did was I just took a flat piece and I went all the way across, then I clamped it into place. That way it makes it easier to locate these tabs on the same plane. One of the other things that we did was took the factory Polaris design, and the seatbelt harnesses will come over this bar, then attach here to these tabs. That way, any type of force from your body going forward into a crash or anything is trying to compress the tab versus break a weld and rip them off. All right, guys, check this thing out. We came up with this little design right here, and we think it's going to look really sick. We got the driver's side all welded up and it's tacked on the frame and tacked on the chassis. We had to put some disconnects right here up towards the front so that you can unbolt and pull this front part out, but this thing looks absolutely sick. So we're gonna do a little TIG welding on this front piece right here where this disconnect is, notch that piece, slide it all in place and get it all welded up. Okay, something we wanted to show you guys is these caps that we did over here. What we did was we cut this at an angle so that it was flush with the outside of the razor, and then we took the outside and we cut a piece of steel out and then put it inside and then TIG weld it all the way around, ground it and polished it out to where it's really smooth. These things came out killer. All right, we got the razor cage completely done. We added a couple kickers up here in the front and rolled these bars around. It looks really good. If there was any type of branch or anything to hit, it would deflect it away from the lights. It's really solid. It's welded in really good. We put a couple clamps right here so that we can unbolt and slide this thing down and pull it out so we can work on anything up here in the front separately from having to pull the rest of the cage. You can get these clamps at berkeyracing.com or straight from Super ATV as well. We think the cage came out really good. We just had Matt sit in there a second ago and did a couple measurements above his head. He's got 4 inches of clearance even with a helmet on, so this thing is just radical and we're really happy with it. All right, so now we're going to take the razor cage, we're going to take the tops of the welds and just grind them smooth so that this flat plate will sit on without those welds sticking up and holding it from sitting flush. We're going to take the razor cage off, flip it right over here in the floor, do that, then we're going to flip it upside down, put it on this plate. We're going to weld tabs on the bottom of it to hold this plate on top. The next thing that we did was we laid out all our tabs, we welded them in, and we used a transfer punch to go over the top of each hole where the hole was, prick straight down, and it's going to put a little mark on the backside. Once you get that done and you pull the plate off, you'll have a whole bunch of little dots that you can drill, and when you drill, it'll all be perfectly centered. Alright guys, so we got all of our tabs welded in on this cage and we went ahead and spaced everything out evenly upside down when it was on the ground. But now we're going to take the cage and we're going to bolt the plate on top. Once we get the plate bolted on top, we're going to use this to roll this last edge. Basically what we're going to do is bolt everything together, put a couple clamps right here, clamp this down, and then we're going to put that last row in. Now it's time for a new tip. Roof's done, looks good, time to paint. Alright guys, we just got the bumper done and the rear and everything painted and put back on. This thing came out killer, we really like it. Everything flows nice and smooth. We've got tons of triangulation in the top, so it's nice and safe. The cage doesn't weigh much more than what the original cage did, so we think we did pretty much a home run on this thing. It looks really good. So make sure y'all check us out. You know, we do a whole bunch of stuff like this. Check out Jake Berkey Riot Buggy. Make sure you check out Busted Knuckle Films. This is Extreme UTV, and check out our Rock Rod series too.